on reflection for C++26. So without further ado, I'd like to invite our esteemed panelists on stage. Please come on in. JF Bastien. I work at I'm also a member of the C++ Standards Committee, so I chair the evolution of the language. With us today, we have other C++ Standards Committee members. We have Hana Dusíková. Hello. She chairs the evolution of the reflection working group, which is what we're talking about today. We have Inbal Levi, who chairs the evolution of the library side of C++. And finally, we have Daveed Vandevoorde, who's one of our oldest standing members in the C++ Standards Committee. He's been in the committee since 1995. And so he's done a lot of things in C++.
Not that old.
All right, thank you. And so today, I'm going to be your moderator. We're going to have the panelists here. If you have questions, please keep them to the end. Go to the podium over there and use the microphone. Please speak slowly so that the interpreters can translate what you're saying. So our panelists today are going to talk about reflection for C++26. We're going to start with a few examples in code to show you what the language side looks like. And then we're going to dive into a few panel discussions to talk also about the library aspects and so on. So let's get started with some examples. And the examples on the top right have a link that you can, a QR code that you can use to go see what the code looks like on Godbolt. So you can try out the code that we're showing you today. So without further ado, please tell us what this code is. What is reflection?
Well, reflection is the ability of a program to see itself and to see itself in terms of a programmable entity. So what we're going to do is we're going to be able to take constructs in a program and turn them into a value. Then we'll have magical functions that can do things with this value, and eventually we'll turn them back into something that looks like source code. So in this example, I defined two types, one an enum and one a struct, and we're going to play a few games with them. So we jump to the main function. And the first thing you'll see there's a name of function. It looks like a regular function call, and mostly it is. It's a little magic, but we'll talk about it in a second. Followed by a prefix caret. And in this code, we're putting in yellow new core language features, right? So the caret turns the thing that's after it, which could be a type, it could be an expression, it could be a namespace, it could be a few different things, but it turns into a value of a new type. It's an opaque type. So now we have this value, and name of, given such a value, will produce a string view that represents the name. So that first line, which uses the new C++23 feature to println, but on the Godbolt link, you'll see that it still uses std_cout. Anyway, it will print out my enum, because that's the name of the type. Now let's go to the second line. We still have a caret my enum, so we're taking that same value, but instead of feeding it to name of, we're feeding it to a magical function called enumerators of. What it does is it returns a vector of similar values, except these don't represent the type, but they represent the enumerators, which are x, y, e, f, and z. And so now we can ask questions about those things. So you see that we subscript with subscript 1, so x is 0, y is 1. So we're getting back the description of y, and name of applied to that returns a string view for y. So that prints out the name y. And then in the third line, let's see what we're doing there. We're taking the enumerators off. So again, we have the vector describing each enumerator. We're taking number 4. So 4 will be x, y, e, f, z. So now we have z. And then we turn it back into a language construct. Right, so these strange little brackets with a colon, they take one of those magical values and turn them back into a language construct. So the construct in this case is the value z. So that will actually print the value 99 as a constant. And so you can do the same kind of things with a struct, but instead of using enumerators of, you would use non-static data members of. That's one of the many options for a class, which will return you the non-static data members. And so in this case, you'll get a description for the data member key, flags, and value. We're taking number 1, which will be flags, since key is number 0. And then what do? We print out its name. So that force println will print the name flags. And finally, the 5th line shows that you can even select using these things. So you can do s dot, and you select the non-static data member number 1, which is still flag. So it will print out the value of s dot flags, which is hexadecimal OD, but that will be output as a decimal value 13. Note that this is flag is a bit field, so you could not do this with a pointer member, but because reflection encapsulates the thing, it's almost exactly as if you had written s dot flags, except that you can at compile time manipulate which field you would actually select. So this example is obviously contrived, but it shows the 3 basic components of reflection as we're seeing it. Is 1, an operator to get into a computational domain. 2, a number of const eval functions that allow you to manipulate it. And then 3, a way to splice the result back into the program.
All right, thank you, Daveed. So this shows off the basics of the language feature that is potentially being added to C++ 26. We're going to look at a few more examples of this feature being used. So here's another example here. Hana, do you want to tell us about this code?
Yeah, this is a function. This is code showing how you actually work in context of templates. So we have enum item struct, which will be used later, and we have function get enum data. You pass as a template argument an enum type, and this function will convert it into array of enum items containing name of the enum and value. It does that by operator caret on letter E, which is the template argument, and it will take the enumerator, the enum, calculate its size with size function, and prepare array of the enum items. And then for each enumerator from the enum, it will fill the result with the enum item with the name of the one member or enumerator and value of it. So for in this case, we have my enum with x, I, e, f, z, and it will return array of x. That will be probably 0. That should be 0. Epsilon 1, e minus 1, f. David, correct me if I'm wrong, but it will be, I'm not sure exactly.
It'll be 0.
Be 0 again?
Yeah.
Okay, that will be 0 again, and z 99. And then in main, we have C++ 23 function println, which will print members of name of my enum. So you can actually write your generic code, which will take any enum type, and you can take its name, and call our function get enum data, and print each enumerator with its value as a name equal value.
Perfect. And so we're going to look at a related example to this one, still on the language side here.
So if you have this facility ready, you actually don't need a reflection in your user code much, because it can sit down there, and there is a function enum to string, and you provide enum value, and it will convert to string. It does that by asking for static variable, constructor variable enum data, which will take result of previous function and iterate over it until it finds a value which is matching the value you provided to it, and print its name. If you provide a value which is not inside of enum, it will return unnamed string. unnamed. So in this example, we have my enum, same as before. And if you provide enum to string with a value epsilon, it will give you epsilon because that's the value. Enum to string for f will give you f as a string. But enum to string of my enum 5, which is not there defined, it will give you string unnamed.
Perfect. Let's look at another example here.
Oh, that's one for me, right? Okay, this one's a little more complicated. So what we're going to try to do is take a struct value that we're passing in by const tref, and we're going to try to generically dump its non-static data members. Now, there is a construct here that we have implemented as a library function. What's not shown in this slide is that we are pound including a header called meta, and the expand construct there with those colons around it creates an object that can, at compile time, instantiate a generic lambda multiple times. So what's going to happen here is that the non-static data members of _t is going to feed a reflection value for each member of S, so for key, flag, and value, into the lambda that follows it, right? And it's going to pass those values not as a normal parameter, but as a template parameter, the one that's called record here. And so then record can be passed to name of and to s.record to feed the name and the value of S, the corresponding value of S, to print ln. And so this will just print something like key equals whatever, 100 flags equals 13 and value equals 42. I encourage you to try this on Godbold and play a little bit with it. I mean, obviously these are a bit contrived, but you can see how you can expand the ideas of being able to, at compile time, explore your data structures.
Right, and so one person or library can implement this dump struct function, and then anyone can use it to dump the content of a struct.
Exactly right.
Okay, let's look at another example here.
All right, so this example is courtesy of Barry Revzin. Some of you might know him. And he found that he didn't like command line argument libraries. Now, in this example, we're not going to see how it actually works. We're just going to see what could be done. And this is, again, you can go to the Godbold link and it works, right? But what this examples allow you to do is you define a structure like args in this example, and you inherit from a normal C++ class that makes use of these reflection features. And for every command line option that you want, you just create a field and you type it, you say option of the type that you want that option to map to. So maybe your first option is an option dash name or dash name that has a string argument, right? And then Barry decided to have both short forms and long forms. So if you have a short form, it would be -n. If you want a long form, it would be dash name, right? And then another option that would be count, right? When you call for a default a value of args parse.argc, argv, it's going to do everything and just fill in, create a new structure with a field called name and a field called count that has the values that you passed on the command line arguments. Not only that, if you, for example, didn't pass a count argument, it will figure out that there is a default value in the args description, and so it will give you that value. And so with just a little bit of declarative code, you have a complete parser for your command line arguments. And so this, like say if you call this function with --count to --name Tokyo, it will print twice hello Tokyo.
Perfect. And so this shows how easy it is to create some language features, to create a library, to then create something like a command line argument parser that would, say, look similar to what you might do in, say, Python or another language.
Right. And in fact, this particular example, I think, was expired by Rust.
Okay.
Right.
Okay. Well, so these were a few examples of the language side and how we might apply it. The paper P2996 has a bunch more examples. So if you follow the QR code or go to wg21.link/P2996, the actual paper is fairly long, but it has a lot of justification and examples and so on to show more information on this. And so now we're going to move to more of a panel discussion where we're going to talk about not just the language side, but also the library side of this feature. And so to start off, Inbal, as the Library Evolution Chair, the language creates these new features that the library can hopefully use. And so can you tell us about how you think the library will end up using reflection?
Sure, I'll be happy to. So first of all, hello everyone, and I want to thank my esteemed colleagues for working so hard on this proposal. I think it's amazing, and I always say that you're working really hard to help us do better libraries, so thank you for that. um, so first of all, I want to address this question in the wider scope. So before going into library, I just want to talk about code interaction and communication. So reflection, I think, is a very interesting feature. So first of all, before going even to the library, just two pieces of code it needs to be able to interact. Reflection by itself is already exposing something way wider than what we have in the language contract. So basically, we're doing, yeah. I've noticed that Hana left for the mention of contract, which is another feature that we may have. So we basically expose something that is wider than what the C++ language now have between two pieces of code. So first of all, I think it's very interesting from that aspect. And I also think that it means that we need to carefully consider what do we guarantee. But going into the standard library, which is a bit of a different aspect, so there's two things here. First of all is that we could technically, we could have in the future libraries that rely on reflection, assuming that we'll make the promises and the guarantees correctly, as I said, which is not a trivial assumption. And that would be very interesting. So the first thing I expect is that after we'll have the language feature, we'll be getting more proposals for library written based on this, which will be very exciting. And the second is that at some point we may even start to see user code that try to interact with our standard library, possibly using this. So I can go back a few like for looking at the bigger picture. Generally speaking, what we're looking for in library is ability to communicate, as I said, or interact with other code. And that is a term being referred to as customization points. So I'm very interested to see how reflection can be used to actually achieve those. So yeah, thank you very much.
Great, thank you. And so beyond the library, I think one of the language design criteria that C++ usually follows is what we've termed, you don't pay for what you don't use, right? And so what that means is if there's a C++ feature that you're not using, the language tries to not have a cost either at compile time, the code size, or runtime because you're not using that feature. And one of the problems early on in the discussions of reflection from a long time ago, say based on Java reflection, is that there is a cost to a lot of reflection implementations. And type info is a part of C++ or exceptions where there is a cost even if you don't use those features. And so my question to the panelists here is there a cost to reflection? Once we add reflection in C++ 26, if I recompile my code just to C++ 26 and I don't use reflection, is there an added cost?
In this case, no, but it doesn't. It's not actually true that you don't pay what you don't use. You always pay in something, in runtime, compile time performance, in your developer like time, or any other resources, and you need to choose what you are optimizing for. I think static reflection in C++ is a little bit different mechanism than Java's. because it provides you mechanism to query anything in the language, almost anything, as far as I know, and in the library and build on that. But only if you use it. Then if you use it, then it will do some computation. It's like typical compile time programming when you spend some time, and it can be slow, but people like David and others work hard to make it faster. And at the end, you can build runtime library like Java Reflection and get some runtime metadata to be usable later. But we think that Reflection, as Grant proposed it in C++, is a good stepping stone for most of, I think, all the features of runtime reflection, but you can choose what you pay for. Sometimes during compilation, some additional symbols or objects will be created, but compiler is good at getting rid of them. So at least in binary size, you won't pay much, only what you are using, but you will pay in compile time, and that's going to get better.
All right, and we have some amount of implementation experience with this reflection proposal, right? If you follow the links, they all work. And so maybe, David, you can tell us a bit about your experience on this kind of trade-off.
Yeah, so the implementation itself is not particularly hard. We're providing basic components that you can build up with. So from an implementation perspective, I don't think it's slowing down compile time. I don't think it's all that big an investment for implementers where, well, because you have reflection, we're not going to be able to work on feature X for the next few years. It is a few man-months to implement this, but it's not a huge feature. On the other hand, I think from a committee perspective, this is a dangerous feature because it allows code to start depending on things that it never depended on before, right? Imagine that someone starts to depend on the names of private members of stud vector. So that's where, as a committee, as a community, we're going to have to spread the word that you can't do that. I mean, yes, you can technically, but it's on you, right? On the plus side, this is type safe, so we're not introducing new kinds of undefined behavior or safety problems. But there is a new way of thinking, right? Just as we have to think of ABI all the time. Here we potentially have a new constraint, and so we have to establish the rules so that the language can move forward while still providing all this power to programmers.
Got it.
I'll be happy to also respond to that. So yeah, I just want to refer to what David just said, and I agree completely. So mostly out of interest, but in the past year I've been running this small group of people with a lot of interest in reflection. I think it was even before the proposal was published, I'm not sure. One of them is right there, and others as well. And they have been writing very interesting papers addressing those things. And I think we're going to see a few papers that coming up talking about those limitations or restrictions that we want to take upon ourselves in order to avoid clashes. For example, parameter names in different declarations of a function is a good example for a paper. Others as well. And I'm sure that me and my co-chairs for Library Evolution are going to explore them very thoroughly and try to deduce what it means for a standard library.
Got it.
Thanks.
And C++ is known as a multi-paradigm language. It's not just an object-oriented language, so it does many things at the language level. Some would say too many things. And one of the things that the group I chair ends up doing is seeing a lot of language proposals to add new ways to do things, new features. And it's always difficult to balance, this feature seems nice versus do we want to do this as a library, right? So some examples is for a while, before C++11, there was attempts to do, say, lambdas inside of a library because we weren't sure that lambdas should be a language feature. Turns out that lambdas as a library was kind of a bad idea, right? So we decided to move them as a language feature. Now, what's interesting with reflection is it's fairly powerful, and it allows you to move some features from the language as a novel language feature into the library. And so I'm wondering if our panelists could tell us a bit about the type of feature that we might see moving from the language to purely the library side.
I can give one example. If you go back a few slides, I don't know if you can. Do we have the ability to come back a few slides? This one, next one, next one. So you see you have that expand construct there. Well, the committee is currently working on something called expansion statements. If you're interested, the paper is P1306, you can look it up. But we haven't implemented it yet. Well, with this thing, which is completely written in terms of standard C++ plus reflection, we have most of the abilities of expansion statements available already. So expansion statements still have an advantage overall. It's easier to use and it has some additional capabilities. But here we have a thing that could not have been done before and which feels like it's a core language feature, but in fact we have turned it into a library construct. And you know, the reflection, we were saying it's a multi-paradigm language. In a way, reflection is almost like a paradigm toolkit where as a library writer, you become a little bit of a compiler constructor. Maybe not the nitty-gritty, but you have building blocks with which you can create new things that feel more like core language construct than the traditional kind of library. Back in the 1990s, people were talking about smart libraries, and I think that's what we're moving towards too.
Looking forward to that.
Got it. And I think some of the examples in the main paper, so P2996, there's examples on library features that already exist that would become more interesting with reflection. I think tuple is one of the examples that's mentioned in there, that implementing tuple becomes much easier, at least, right? If anyone's looked at a library implementation, tuple, it seems easy, but it's actually significantly complex. And with reflection, it becomes much, much easier. So I think as a tool, reflection becomes interesting. I don't know if there's other library features existing or in flight that you think might see kind of some reflectionization as we move forward.
Good. I think there is a plenty of things we can revisit and try to keep ABI same, which is going to be hard, but we can make things much easier because we can specify them not in human language, but as a C++ code. And that makes everything easier because we can reason about C++. It's much harder to agree what English means sometimes. And but from functional point of view, we can look at things like preprocessing as a part of your build system. When you process some file into your C++ code, you can get rid of this part of your build system and just compile C++, and it will work. And many more with other functionalities which are not exactly reflection, we can build things like we can actually compile different languages into C++. But that's future. We will probably go.
Right, so there's often language bindings like to Python or something like that, or the other way around.
JavaScript, Python, things like pipebind maybe will be think of past. You will never need it anymore because you just include library, header only library probably, and it will do that for you. And JavaScript, and I think the interaction between languages will be much easier and type safe.
Yeah, and I agree. Bindings is a major use case, I think, and a lot of companies needs that for different reasons. And that's another good way, a paper that discussed in this group that I mentioned. There's parsing of basically what Protobuf is trying to do, or doing very, very nicely, but we could do quite a lot of things. I'm thinking of some logging facilities that be able to reflect on your source code and give you more information. There's quite a lot that we can do with that. Yeah.
And Hana is actually a world expert in regular expressions and compile time regular expressions, and I suspect that she's going to do some magic with this,
Yeah.
where you know will further improve on the state of the art in that area.
It's a shame to talk about regular expressions here. I think
I concur.
yeah, I think a lot of people will once they will able to play with it, they will get with things we never think even like it's possible. So we will see many more new use cases, and it's going to be a renaissance of C++, I think.
Yeah, and even today we're talking. So we're talking about there's some existing library things that we can write better, but there's also we have in the language hybrid things like coroutines where a bit of it is in language, a bit of it is in the library, or like even a range-based for and so on. Today we're talking about pattern matching, which has a similar structure. There's a bit in the core language and a bit in the library. But reflection was actually discussed in that context because it allows for new ways to move things from the complexity of having to implement it in the compiler to just put in a library where you can iterate faster, where you can customize a lot better. It opens new avenues because you can now refer to language elements by name, by string, if you will, or by number or by value, instead of having to hard code it into parser.
Got it. And so we're giving, with reflection, a lot of power to users to be able to effectively tune the language to what they want to create, right? And right now you can already obviously do this with libraries. There's a lot of C++ libraries out there. And we'll see, as you were saying, kind of a renaissance of C++ and being able to do many things on the language side as well. I think you mentioned protobuf, Inbal, and protobuf and other kind of code generation tools are used extensively, right? Every large code base has a few code generators. You'll have a parser in Python that takes IDL, right? So some description language, and that will generate some C++, right? It's a time-honored tradition to do that, either using a kind of scripting language to generate C++, or using a nice mix of C macros and template, just mix it all in. I have sinned too, and this is what you do, right? A lot. But this is what you do when you don't want to write a lot of code, but you want to generate it, right? So X macros, for example, is something that people do where you pound include something to generate code in your compiler. And when you do that, it tends to be complex to understand, right? You create a separate thing that then you try to give the compiler, generate a lot of code. Reflection would help with this as well, right? Bring things that you do externally or that are hard to maintain, hard to really create a nice language, and instead just allow you to do that inside of reflection. So I don't know if you can, each of us, give us some examples of this.
I already used all my examples. No, I do want to address this. I don't know if examples, but I think it's very interesting. I think one of the first discussions of reflection, I think maybe it was in 12, 14. I'm not sure, but maybe even a previous paper, I was like, triggered the question for me because we do, like in previous places that I worked at, we used the Jinja and for code generation and things like that. And it really triggered the question for me, like, what do we want to do in reflection with in comparison to external tools? And I think that there's upsides and downsides for both. It's because it's part of the language. We get what the regular tools that we get from the language, and when you use an external tool, you get some kind of a responsibility separation. So in a way, and then of course you have your pipeline in order to compose all of those together. So in a way, on one hand, it's a benefit because you don't need to now get any external tools. You don't need to integrate anything into your pipeline. On the downside, you get something that is even more, that may be more hard to debug or reason when you have errors. So we need to be very careful, and I think we actually discussed this in the evolution discussion, the shared joint session for evolution and library evolution, that the way that the form of the errors that you get when you try to use this tool is very important, because thanks.
Yeah,
I didn't give any examples, sorry.
I have a few examples. First, which came to my mind, is things like link. In C#, you can manipulate data, like it's a database, and it will create everything for you. So we will be able to write SQL statement in C++, and it will create a C++ code which will manipulate data structures like ranges, but for most of people, maybe a little bit accessible. And people will be able to use patterns known from different languages. For example, in the CTREI library, you can write a regular expression, and by some not nice code, you can actually interpret it as a regular expression. With reflection, you will be able to just generate the code nicely. So you will be able to just write the code as you write normal code for regular expression. And you can do not just binding. Yeah, you can integrate between. You can generate a shader for GPUs. You can do anything. So I'm looking forward to it.
I think in general, people are often talking about domain-specific languages like DSL, and this opens up a whole new world for those. I mean, certainly SQL is one. We also, reflection tends to magnify other features. For example, we recently, I think we approved, or we're about to approve, pound embed. And you can imagine that, so pound embed allows you to embed a file that's data. You can imagine that maybe that data would be some JSON data, and you could have reflection automatically create the data structures to absorb all that and just go through that data and do something. Now, one of the other things that's a great benefit, I think, about moving away from external tools to internal tools is it simplifies your build system by a lot. I find that porting code, C++ is usually very portable, but your build system is often really hard to port because a particular tool is not available on a platform, or some script made some assumptions about the local data representation and so on. And so if there's fewer contexts in which you have to think, you'll be able to have fewer bugs and a more easily ported software stack.
Sounds great. And Hana mentioned CTRE. If you haven't looked at the heroics she's pulled in CTRE to make fast regular expressions, she effectively has an entire compiler in compile time templates to optimize regular expressions in compile time templates. This is the type of thing that
I think you can embed JavaScript, Java code, and compile it into C++.
Not sure I want to go that far.
You can.
You can.
Someone will.
But I think like an example similar to what CTRE does, compile time regular expressions, is an older library called Eigen, which is a vector and matrix library, right? So it takes kind of like Fortran-like code meant for kind of compute, so vectors and matrices. And it doesn't just do the naive matrix implementation. It goes in and looks at the size of the input vectors and matrices and does blocking and SIMD and everything like that, and boils down to assembly level. And again, just like CTRE, it has a nice little compiler written in template metaprogramming, which if you've written template metaprograms, you end up regretting after a while.
Yeah, don't do that.
And misspent youth in a way. And I think Eigen has the same advantage that CTRE would have of if someone were to rewrite something like this, you could help the compiler understand your code better, right? Instead of the compiler having to be finely tuned for your specific domain, right? So I think the domain side is really important.
Yeah, it will be like first time programming without tied hands.
So it's funny that you mentioned that because my personal path through metaprogramming, which started in the early 1990s, was motivated by the desire to optimize a linear algebra library like Eigen. Of course, mine was not anywhere close to Eigen, but I ran into all these problems where you have an expression and you want to optimize it, but you have no way to look at the expression from the point of view of the language.
Yeah. All right. Well, thank you. So we're going to move on to the Q&A section of our panel today. So thank you, all of you, for being here today. If guests could line up, maybe ask questions, please make sure that you speak slowly. Japanese is okay, as well as English, and we'll have the interpreters translate for us. While we wait for people to come on to ask questions, please line up. Just to be clear, we're meeting in Tokyo this week, the C++ Standards Committee. This is not in the draft of C++ yet, right? So there's still quite a few revisions to go through before this can be in the language. So while people line up, you're the chair of Reflection. Can you tell us, the process that we still have to go through to get this approved?
Okay, the proposal currently is in evolution working group, and there is a plenty authors need to do. They need to write wording for the paper, or at least finish it. It needs to be reviewed by also library evolution group because there is part of the library design. They will spend a lot of time by sharing the names first.
That's what we do.
Yeah, that's exactly what you do. And also because we want to make it the best possible, it needs to go to other study group, namely Unicode study group, because we want to support Unicode, because not everyone is using ASCII. And and then it will go again to evolution working group, and then we will forward it into core working group. I think I see them there, and they will have fun. They will spend a lot of time together trying to understand what we meant and if it's correct. And if they agreed that it's what we want, then in terms of international standard, it will be done and implementers can implement it. But implementers already implementing it. We have two implementation. One is in EDG from Daveed, and one is in Clang from Bloomberg. And so it will be ready quite soon. It's not final version, but it's actually available, but you can play with it already now. It's on Godboard. All the links are working.
Yeah. And the one from Bloomberg is by Dan Katz, and I think Quarantine also helps. Thank you for that.
And I'm starting a Patreon so that we can collect the amount of money that we'll need to bribe the esteemed Inbal here to let the proposal through early WG.
It will be a lot of money.
All right. So thank you. So we have a few people who have lined up for questions. So please speak slowly so the interpreters can pick up your question. Please, go ahead.
So it's not really a question, but just addition about the example that could benefit from that. Basically, in my opinion, stdcmd library feature would benefit hugely from that proposal. Because I'm not going to go into the details, but if you want to support user-defined types, right now we only support integral and state complex, I guess. But with that, we can just scan the type, see if it's suitable for stdcmd, and then even transpose it from array of structures to structure of arrays, and be done, and make our code faster, more optimized, and that's it. I'm sure who is familiar with problematic standpoint, understand what I'm talking about. Thank you.
Yeah, so that's one interesting language side and library side where you can reorder members in a structure.
And thank you for bringing that up. The paper actually has a structure to structure of arrays transformation as a compelling example.
Yeah. All right, we have someone else here.
So based on what you've said so far, say a state machine compiler would be like Child's Play, right? Probably, or?
A gifted child.
Fair. But I wanted to ask about define class. That's something that's in the proposal, and you guys didn't talk about it in your examples, but it seems like a very powerful aspect of it.
Injection.
Yeah, I'll take that. So we did not talk about all the details of the features. There are dozens of meta functions that we call. One of the most interesting ones is one that allows you to procedurally synthesize a class definition, and we call it define underscore class. Now, the reason why it came to be is that we have papers looking far ahead for much more powerful features, but they won't be ready for the next 3 years. It's gonna be a while before we have those, but we still wanted some capability to synthesize code, and in particular synthesize simple classes. And so we looked for something that would work, and we came up with this function called define class. And at first we thought, oh, there's not much you can do with it. It seems too simple. But it turns out that C++ already has so many abstraction facilities that if you have something to create a seed, your abstraction facilities can take that seed and make really good use for it. And so, for example, you mentioned the tuple, that how we can simplify a tuple. It uses this define class. You can create a tuple procedurally, very simple and very quickly. And then you need a very thin layer of fairly simple template code to turn into a correct tuple interface.
I think reflection as it is in current proposal gives us 95% of cases user wants. And we will identify the remaining 5% on internet, on Reddit. People will show as example on conferences. We will see a discussion about it, and then we can actually provide something which will be useful.
And I agree, and just want to add, I completely agree, and I expect us to see a lot of talks on reflection, and I'm looking forward to the discussion on those.
Right, because that 5% that's remaining, we're not always sure what it should look like, and so getting the feedback from users already now, 2 implementations are usable, would be very useful. Right. So please don't be afraid to line up to ask questions. Please go ahead.
Questions, not comments.
Okay, so first of all, I wanted to thank you for this feature. I think many developers are actually waiting for it for many years already. I was also wondering that would it be possible to reflect on the functions and methods, class methods, for example, get a vector of all the methods of a specific class? Thank you.
Yes, so the proposal allows you to look at the declarations of functions and the declarations of methods. So you can ask for all the members, including nested classes, nested enums, nested functions. You can ask if they're virtual. You can ask for the base classes and see what kind of base classes they are. What you cannot do yet is look inside the definition of a function. And the things you can do with expressions is also still quite limited. And that's mostly have to do with the fact that all compilers do it a little differently. And so coming up with a workable solution will take a little more time. But certainly we're looking at, for example, being able to type erase a class automatically. That's a goal that we have in the relatively short term.
Actually, there is another implementation of reflection, not of this proposal, but it's a prototype from a French team, and they have a reflection on expressions too, on function, on statements. They are going much deeper, and it's a really interesting exercise on what can be done and how, because it's always easier to argue about something existing than something which everyone can imagine differently. So, yeah.
Please go ahead.
Yeah, now I have a question.
Wonderful.
So, this feature is very powerful, but probably too powerful. So, and the thing is, some might use it like as the engine which generates and executes the code actually, as far as I understand, and as the parser of JSON, or whatever. Do you envision any extra security problems with that somebody can scan the code, understand what it's doing, and use this exploit to, I don't know, do something malicious? Thank you.
I think I will start. in Prague a long time ago at C++20 release meeting, we had a discussion about that, and we discussed different compile time models for reflection, more imperative. And in that model, you can actually do anything you can do in runtime C++. So you will be actually able to take a library from system, link it, and use it. And if that's not scary, I don't know what it is. I was actually thinking with that, we would probably see malware inside of C++ code, because you will have I/O available, so we'll be able to change the code, change the meaning, and inject your malware into binary, and it will spread silently. It's scary, yes, but I think current reflection is limited because it can output only into the binary you are producing, and it can only consume your source code with bound embed some other files, but they must be explicitly visible in your build system. So then it's exactly same as C++ already is, no more or no less.
Yeah, so to expand on that, so we've talked about this bound embed feature, which allows you to grab a file and bring it in, like expose it as a bunch of data. Well, when that was proposed, a more general feature was proposed where you could just say stud : embed /dev / some device, and you start reading your device. And that's when Vander said, wait, no, we can't do that. The thing about pound embed is that you can actually control which files are visible to the compiler, because it goes to the same sort of thing. Like just like pound include is a dangerous thing, right? Like if you give pound include access to your whole file system, who knows which file you're including? And so in the same way, we need those controls. It's a good question, and it's certainly something we should keep in mind.
But we have a group for that.
Yeah, so we actually
Study
have a study group in C++ for safety and security as well.
Yes, 23.
All right.
Hello. Would this mean that reflection would also work on opaque data structures?
Can you elaborate what you mean by opaque?
For example, idiom that come to mind is, for example, the pimple idiom, where you try to hide certain implementations from the user by just putting everything in the source file and explicitly remove it from the header file.
That's a good question. So reflection cannot do miracles. It cannot see what the compiler cannot see. Reflection just emerges what the compiler sees. But you can create protocols where maybe the .c file that has the implementation could create a data structure in binary and at runtime that now shows, it can be used by client code. But that's then something that you'd have to compose with your own library. A bit like we did in the Enum example there on the second slide, we took some compile time data and put it in a runtime array. So you could do something like that, but certainly it cannot see through the pimple idiom.
Okay, so that would mean someone who wants to hide some parts of the implementation can do that, and it would not be possible to leak everything that was explicitly hidden in some source file.
That's correct. Without cooperation of the implementer, we cannot access it.
Okay,
Yeah.
thanks.
Yeah, you cannot cross translation object translation unit boundaries. You are still there, like you are in ConsExpert, but now you have to inspect anything in code you can see from that ConsExpert code.
All right, and last question for today. Thank you.
I suppose the answer might be no, but I still want to ask, can you generate functions with that? I mean, my use case is you have some specification that you have to program to. You write your implementation, but you would like to have unit tests for that, your code being generated. Can you do that?
So currently, the only way to generate code is by a bit like we do now with instantiations over lambdas and things like that. We are looking at the more general injection mechanism, but that's not going to be in C++26. I am not even sure it'll be in C++29, but we're working on that actively, and we're looking at several alternatives, and it's of great importance to a lot of people.
So with a little bit of trickery using my own lambdas and that kind of things, I could inject them at least, right?
That's right. Yeah.
Okay, thanks.
All right. So thank you everyone for coming. This is our biggest meetup ever. So thank you for coming. Special thanks to our staff. I know this was a lot of work. There's a lot more people than usual. So thank you very much. And thank you for our panelists as well. And for everyone who's worked on Reflection so far. It's been a pretty big team effort and many years in coming. So I hope we see this in C++26. So thank you everyone. We're going to close the panel now. Before we leave, I'd like to remind all the attendees to please return the Panic guides, right? So the translation devices to the staff. So thank you very much.
Thank you. Thank you, Jeff, for having us.
Thank you.